Okay, so this is the problem from homework 7.6. I believe it's question 5. So similar to this, you might not get this exact problem, but I'm gonna go through some of the algebra at the very end because one of your classmates asked that. So the question was, it says use the figure to evaluate the following function, given that g of x is equal to cosine of x, and we're trying to find g of theta over 2. So that's our question there. Okay, and we know that the half angle formula for cosine theta over 2 is this. Cosine theta over 2, which is the half angle. This will be given to you during the exam, so you don't need to memorize it. It will be square root of 1 plus cosine theta over 2. Okay, so g of theta over 2 means we're inputting theta over 2 to cosine, right? So just copy paste this. The only missing part here is cosine theta. This is like a side note, right? We're trying to find cosine theta. So you would say cosine theta is x, right? X over r. So in this here, usually we know it's x over r. They say x is a. On a unit circle r is 1, but in this circle the radius is actually square root of 7, because x squared plus y squared equals to r squared, or radius squared. So if r squared is 7, then r is square root of 7, right? Plus minus square root of 7. But since it's radius, it's going to be positive. Okay, so again, we're still missing a here, right? So we need to set up a triangle, right? Triangle, using the information given. So we know the radius is square root of 7, which is the hypotenuse, and they gave us this coordinate here. It says a and square root of 3. So a is the x, and then square root of 3 is your y here. So to solve for a, use Pythagorean theorem. So hypotenuse squared minus one of the sides squared is the other side squared, right? So a is square root of square root of 7 squared is 7, minus square root of 3 squared is 3. So a is square root of 4, which is 2. Okay, so that's our missing piece there. 2 over square root of 7. And since we don't want a radical on the denominator, we're going to multiply square root of 7 on top and bottom. We get 2 square root of 7 over 7. I'm going to elaborate on this just in case you forgot. Square root of 7 times square root of 7 is the same thing as, you can combine them. The square root of 7 times 7, which is square root of 49, and we know that is 7. Okay. Alright, so we know what cosine theta is. So you just plug it in into this equation here. So the complication comes from here. Before we do that though, we need to notice that since a here is on quadrant 2, a is going to be a negative quantity, right? So this is actually negative 2 square root of 7 over 7. Because on quadrant 2. Okay, so I'm gonna restart it here. Cosine theta over 2 is square root of plus minus square root of 1 plus cosine theta over 2, and we know that cosine theta was 2 square root of 7 over 7, and that's it. So again, the hardest part here actually is to do the calculation with all the radicals, and that's what we're gonna do. So I'm gonna work on the numerator here. Since we want to have the same, the least common multiple on the denominator, I'm gonna make 1 as 7 over 7 so that we can combine the numerators there. So 7 plus 2 square root of 7 over 7. That's your numerator, right? Since we are dividing by 2, it's the same thing as multiplying by 1/2. So I have 7 plus 2 square root of 7 times 1 over 14. Okay, so that's all underneath that square root. I'm just gonna move things here. So all of that square root plus or minus in the front. Okay. Oh, sorry. It should be minus because even though that's our this is our original formula, but because again A is on quadrant 2 here, it should be negative, right? Okay, so all right, so if we were to rewrite this, it would be square root of 7 minus 2 square root of 7 over square root of 14, and you can multiply square root of 14 top and bottom, and you would get 14 on the bottom, which is nice, and square root of, you know, multiply 14 by everything on the inside. It's a bit messy, and that's about it. That should be your answer. All right, that's it.